Good morning, I am UC Patnaik. Hope you have subscribed to my channel. Now let's proceed to the topic. In robotics, we use several type of motors. One of them, the most simple one, is the DC motor. This is a DC motor and it got two wires only. One is for the positive, one is for the negative. And while we connect it to the DC power supply, or a DC battery, we will see how it behaves. We have mounted the motor with a blade on top of a compartment, and now we will give power to this motor. We take another battery and we try to connect this position of this positive and negative. We connect it this fashion and we see the shaft spins at a very high speed. And if I reverse the battery polarity, we find it spins in the other direction. What you can notice, it spins in the other direction, and in this we have noticed it spins in the clockwise direction, as you see from. And if we reverse, we find it spins in the anti-clockwise direction. That means while we reverse the battery, it happens either clockwise or anti-clockwise. This is the basic fundamental of using DC motors of anti-clockwise and clockwise in any robotic applications. What we noticed, that this motor with this blade was spinning at a very high speed. Such high speed cannot be utilized for any kind of robotic application in, say, an automobile application, where we have to use, in automobile applications, we know we use some gears. So what we do is, actually I have removed this motor from this, where the motor was mounted here, and what you can see, there are gears inside. What you can see there is a gear inside. So because of the gear arrangement, what we find, and we can reduce the speed. So we will see a motor with this mechanism attached and find out how the speed is reduced. Now we have connected the motor to its original housing, so it becomes a geared motor. When we apply the battery power, you see it spins at a very low speed because of the gear arrangement. This is in this direction, whereas we put it this way, it spins in the other direction. So this is how, with such low speed, we can always try. In actual practice, we will not be reversing the battery. We'll be using some electronics to make it automatically happen, so that when we use this in some kind of movement of a vehicle, its forward movement and reverse movement can be controlled based on the electronics that we use. We also use little powerful motors for bigger size robotic vehicles, and they are geared motors. It has similarly two pins, which one can be positive, one can be negative, and when we reverse it, its spinning also reverses. We will watch it now. We have mounted a similar motor on a bracket like this, because using the motor has to be in certain arrangement. So this is the bracket that we have used, and the shaft is this, which will be spinning and which will be noticed by this nut bolt that we have provided. But anywhere you can always put a wheel, which will be the wheel of the robotic vehicle. Now we have given power to the motor, and we can see how the shaft is spinning at a speed of anti-clockwise. And while we reversed it, it spins in the clockwise at that same speed. So similar, the control can be by electronics only, not by physically changing the battery terminal. We also use stepper motors, but typically they have some 5, 6 or 4 wires instead of 2 wires, which we have noticed in the simple DC motor. They have got number of, and they are run by a special circuit and sometimes the program. So we will see that at the later part. This is again some powerful stepper motor. It can do much extra work compared to the small stepper motor we have just seen. We also use another motor which is called a servo motor. if you can compare the size of this of the battery, this is very small in size, and this is a servo motor, and it's called a 9-gram servo motor that we can see here, 9 grams written here, 9G. And we also have higher load servo motors. This also is a servo motor, but this is the shaft, and it can take much higher load, used for robotic applications in pick and place, humanoid robot, and many other applications. This is how a stepper motor works. It moves in steps. We have made a program to spin at 360 degrees from one side to the other. And this is the electronics board which is used, and this is a Arduino. It's a programmable board where we program it for this, and then obviously the power supply has to be given. And it runs on the program as we mentioned, and the program somewhat looks like this. We have to define certain pins as far as the program is concerned, and then we go on writing the program, and based on this program, the function, it's a Arduino program. Based on this program, what we find, it works as per the program written. It goes this side and the other side. It spins this side and the other side, as you can see it here, as per the program. A servo motor like this, a servo motor can operate with a programmable board and power supply, of course, and then it's a pan and tilt. We will see how the pan and tilt operates with this program. Now when we change this, we find that it is making up and down, and while we change this, it makes sideways, left and right, So this is what is pan and tilt arrangement of a program that is to be used for operating servo motors. However, it can also be used for Arduino if the program is written correctly and a Arduino board is connected. Such boards support about 16 such servo motors to be used, and for many actions the number of motors can be used, and then it can be programmed here to operate as per the requirement. Here we have an arrangement where we have two motors. One motor is here, the other motor is here, and they are connected to worm gear. We call it a worm gear, and there is another two gears here, so that this gripper, it is called gripper, this gripper will operate. We will see that while we use it. And this one also has a worm gear, and this will be operated by this motor, and there is a worm gear beneath this also, and this will make it up and down. So in robotic applications we can use this as a pick and place, where it can come down and then pick something here and then go to some other place. This is what is a pick and place arrangement with a gripper, and we will see that function now. So when we apply power to this motor, and we see how the gripper is opening, and if we reverse the power, and then we see how the gripper is closing, this gripper closing. So this is what is the function of this motor. Similarly, for the other motor, what we can notice, this motor, where, so when we apply power, we find this comes up, and when we reverse, this goes down. So this is what can be used for pick and place operation.